Good morning. I am Dr. Jyoti Kumar. Today we are going to discuss about the topic process state in operating system. In five-state process model, we have a new state, running state, waiting state, ready state, and termination state. New state, the process is being created, or when a particular program is going to be get from the secondary memory to the primary memory. Here we can represent it as a new state. When the process is created, it is ready to enter into the ready state. Moving to the running state, the instructions are being executed. And when I'm coming to the waiting state, the process is waiting for some event to occur. Ready state means the process is waiting to do to be assigned to the processor. Coming to the termination state, the process has finished its execution. This is the diagrammatic representation of a process state. We have a new, ready, running, termination, or terminated state, or a waiting state. As I mentioned you already, new statement, the process is created, and this process is admitted to the ready state. Once the process is admitted to the ready state, and this process is ready, process is ready to move to the running state. And we have n number of processes which is entered into the ready state. We can save or we can keep that particular process in the ready queue in a ready state. And each and every process is going to move from ready state to the running state based on the availability of the CPU. Once the process CPU is ready, the ready process, the ready state shares the process to the running state. And this running state is going to execute the particular process. And once the process has complete its execution, it exits through the termination state. Or if the particular process needs an input-output request, it moves to the waiting state. And then this process was complete its input-output request. Then it again the particular process moved to the ready state, and now this process is ready to move to the running state or to move to the CPU once again. This is a five-state process model. In new state, a process created and it is entered into the ready state. We have n number of processes which is entering into the ready state so that we can maintain a ready queue. And each and every process which is in a ready queue is ready to move to the CPU, or we can term it as running state here. And now when the process is entered into the running state, the process is in execution and it leads to termination after completion through the terminated state. Or it again moves to the waiting state in case of input-output request, and this process was completed and it again moves to the ready state. Suppose if there is an interrupt occurs, a priority process is going to enter. In that case, the current running process is going to move to the ready state, and the prioritized process is giving a priority for executing the program, the CPU. Once the prioritized process is complete its execution, it exits through the termination, and then again the process which is suspended is again get back to the running state for the execution. So the prioritized process is entering into the CPU, so the currently executing process is going to suspend. So in that case, I can term it as an interrupt here. So this is the five-state process model. Coming to the process control block, we have a process state, process number, program counter, registers, memory limit, and list of open files. Process state means it shows the current state of the particular process. It refers to running state as well as waiting state, and so. When I'm coming to the program counter, okay, the locations of instructions to next execution. Coming to the registers, the content of all process represents the centric register. And then when I'm moving to memory management information, the memory allocated to a particular process we can represent. And then we have IO state information, IO devices allocated to a particular process, and list of open files are represented. So the main important thing, process number represents a PID, process ID. For each and every process, the process ID was created. and even using process state, the state of the current process is being identified. So the entire thing we can term it as a process control block. Coming to the context switch in CPU, here, as I mentioned earlier about the prioritized process, which is requesting for execution. So assume that here we have a process 0 and process 1. The process 0 is started executing here, and then the process 1 is assume that it's a prioritized process and it is requesting for CPU. So in that case, the process 1 have to suspend. I have to suspend. So what exactly happens here? Till the execution, and the process 0 was saved in PCB, and reload the process 1 for execution. Once the process 1 was complete its execution, again it's saved in PCB 1, and then it reloads the PCB 2, reload the process 0 in the PCB, reload at the second process 0, and then it starts its execution. So it is going to switch the process from process 0 to process 1 for the execution. After completion of process 1, it again switch from process 1 to process 0. This is actually a context switch. Thank you.